Hello, and thank you everyone for tuning in to the Science Salon podcast. I'm your host, Michael Shermer, and I bring you this show from California once a week as part of the larger mission of the Skeptic Society to promote science and reason, and to ensure that sound scientific viewpoints are heard worldwide. As a 501c3 nonprofit, we rely heavily on the ongoing and generous patronage of listeners like you. To pledge your support, please visit our website at skeptic.com/donate. Thank you. My guest today is Dr. Brian Keating. He is the author of Losing the Nobel Prize, a story of cosmology, ambition, and the perils of science's highest honor. Brian is a professor of physics at the University of California, San Diego, a fellow of the American Physical Society, a commercially rated pilot, and the director of the Simons Observatory. He received the 2007 Presidential Early Career Award for scientists and engineers for his work on BICEP, and he lives with his family in La Jolla, California. So we get into all of his details of all of his work with the BICEP Observatory at the South Pole, which along with another experiment, basically confirmed inflation theory of immediately after the Big Bang. I mean, just like microseconds after the Big Bang, what happened to the universe that way. And as he explains in my conversation with him, why do they have to be at the South Pole? It has to do with how much moisture is in the air for collecting the data that's coming from very, very far away. Anyway, Brian came onto my radar because Ben Shapiro had mentioned him when I did Ben's show last year. And then I noticed he did a Prager U video for Dennis Prager. So I wondered, why is this experimental physicist getting praise from Ben Shapiro and Dennis Prager? Well, first of all, he is Jewish, as are they. But is he a theist? That's what I was curious about, because there's usually a reason why other theists lean on certain scientists rather than others for scientific research that appears to support their religious beliefs. So you will find out in the last third of this podcast exactly what that means. Turns out actually not nearly as much as they think it means. Interestingly, I found Brian to be incredibly honest and open with his ideas about this particular subject, science and religion, and to what extent science can support religion. Not much, but not entirely null either. So we get into that, and but also the competitive nature of science, the shortcomings of the Nobel Prize, and how unjust it is to so many people. Not just all the people that work on an experiment, and only 3 can get recognized. But the dearth of women in the history of the prize, and so on. So we get into all that as well. And I read a short portion from an issue we did of Skeptic. The cover story is "Why Is There Something Rather Than Nothing?" which I wrote. Now, I'm not a physicist or philosopher, but I'm kind of compiling in this article all the different answers people have come up with, philosophers, scientists, and so on, about nothing. And this in particular, there's a good book that I was working from by John Leslie and Robert Lawrence Kuhn called The Mystery of Existence. Why is there anything at all? And so I start off by quoting Stephen Hawking from his A Brief History of Time, who so eloquently outlines the problem. What is it that breathes fire into the equations and makes a universe for them to describe? The usual approach of science, of constructing a mathematical model, cannot answer the questions of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? Okay, so that kind of cuts to the core of this question. Why is there something rather than nothing? So I read a quote from Robert Lawrence Kuhn. Let me read it again. This is the first of half a dozen different answers to the question, why is there something rather than nothing? The first is, nothing is inconceivable. First, as suggested above, it is impossible to conceptualize nothing. No space, time, matter, light, darkness, or even any conscious beings to perceive the nothingness. As Robert Kuhn conceives it, quote, not just emptiness, not just blankness, and not just emptiness and blankness forever, but not even the existence of emptiness, not even the meaning of blankness, and no forever. Close quote. That's inconceivable. The second answer, something is nothing. No, sorry, nothing is something. This I did not read in the podcast. It's short here. I'll read it here, just to set the stage for this conversation. The analytical philosopher Quentin Smith pointed out to Kuhn that it is a logical fallacy to talk about nothing as if it were something. That is, to suggest that there might have been nothing implies it is possible that there is nothing. As Kuhn articulates Smith's argument, there is means something is. So there is nothing means something is nothing, which is a logical contradiction. His suggestion is to remove nothing and replace it by not something or not anything, since no one can talk about what we mean by nothing by referring to something or anything of which there are no instances. In other words, the concept of something has the property of not being instantiated. The common sense way to talk about nothing is to talk about something and negate it, to deny that there is something. So here we're bumping up against the problem of defining what we mean by nothing and the restrictions that language imposes on the problem. The very act of talking about nothing makes it a something. Or else, what are we talking about? Finally, nothing would include God's non-existence. What? In Kuhn's taxonomy of nothings, he lists what categories of things might be included in something that would be negated by nothing. And here's the list: physical, mental, platonic, spiritual, and God. Physical includes all matter, energy, space, and time, and all the laws and principles that govern them, known and unknown. Mental, all kinds of consciousness and awareness, known and unknown. Platonic, all forms of abstract objects, numbers, logic, forms, propositions, possibilities, known and unknown. Spiritual and God, anything that could possibly fit in this non-physical category, that is, all forms of religious and spiritual belief. If by nothing is meant no physical objects or matter of any kind, for example, there can still be energy from which matter may arise by natural forces guided by the laws of nature. Physicists, for example, talk about empty space as seething with virtual particles from which particle-antiparticle pairs come into existence as a consequence of the uncertainty principle of quantum physics. From this nothingness, universes may pop into existence. But, and finally, if by nothing is meant there is no physical, mental, platonic, or non-physical entity of any kind, then there can be no God or gods, which means that there cannot be anything outside of nothing, out of which to create something. If God is proposed to be outside of or pre-existing the nothing from which the something was created, then why can't the laws of nature that give rise to somethings, like universes, be outside of or pre-existing nothing? Okay, this is just the first page of this long article I wrote. This is a pretty deep subject, and Brian and I get into that toward the end of this podcast. So with that, I give you Brian Keating, and enjoy. Well, let's get started. Thanks for coming on the show. I really appreciate it. I first heard about your work through Ben Shapiro when he mentioned you on when I did a show maybe last year or so. And that's about when your book came out. It's called Losing the Nobel Prize, a story of cosmology, ambition, and the perils of science's highest honor. So I have to tell you, I just to come at this from various ways when I do with my guests is in the 1980s, I was a bike racer, and I got involved in the International Human Powered Vehicle Association. These are these fully fared streamlined bikes that go 2 to 3 times the speed of a regular road bike because they cut through the air and all that stuff. And there I met Paul McCready, who had just won the Kramer Prize for the first human-powered airplane to do I think he had to do a figure 8 on an airfield, and then he won the second Kramer Prize for the human-powered airplane over the English Channel. And when I met him and got to know him, and I asked him, well, what was your motivation to do this? And he said, well, I had a house payment to make. And then he had a mortgage, and then he started his business, AeroVironment, and he needed the prize money for that. And that's what kind of introduced me to the idea of prize money as an incentive for scientific and technological research. And of course, I read Davis Sobel's famous book on longitude and the prize money that drove that. And I've always been a big supporter of that. The X Prize, I think, is great, and so on. But after reading your book, I have to say it's not that simple of just throwing money and a big prize at somebody. It gets complicated when you have something as prestigious as the Nobel Prize. So why don't we start there before we get into your research? You were tasked by the Nobel Committee to make a nomination of somebody. And so walk us through, how does it work? How does one get nominated and then win and so forth?
Yeah, I mean, I describe the Nobel Prize as kind of the most kind of friendly, gentle, likable mafia or monopoly that there is in the world. It's sort of a cabal in the sense that it's very restrictive. There's only a few hundred people that make these decisions that have just the most far-reaching impacts all over the world. And, no disrespect to your friend, but, I'd never heard of the Kramer Prize until you mentioned it. But I'm sure there's many prizes. Peter Diamandis, he wrote a blurb on the back of my book, and he wrote, and great deal about the desire to fund innovation via prizes, which I think was part of the motivation behind Alfred Nobel back in the 1800s when he bequeathed this will to be money to be given away for the betterment of mankind. As I point out in the book is mainly a memoir. There's only 3 chapters about the Nobel Prize specifically, but it was a very strong animating impulse for me. And I know, you and I have talked a little bit about TMT and the terror management theory, and I'm no longer a believer in that after reading your books, but I feel like there is for example, this morning every day I read a book about business, and that sounds strange because I'm a practicing cosmologist. What does business have to do with me? So I'm reading Ray Dalio's book right now, Principles, and in the book, he divides it into many different sections. And at the end of the first section, after he's bequeathed all his knowledge about the business world, now he's going to turn to his principles for life. Dalio's 10 Commandments, I call it. And this page I'm reading today, and I do this because I think you need, as a scientific manager, which is what I am, and part of my career is I'm managing 250 people to build a telescope in one of the world's highest, most forbidding locations. And to do so, I wanted to learn from the best minds in business. How do they lead organizations? So every time I hear he says the word startup, I change that to CMB experiment, cosmology experiment. But today he was saying, like, at the end, the very last sentence, when he's inspiring you to go on and achieve your dreams, he says, think of whatever your dreams are, in life, to make a ton of money or to win an Oscar. And those are the only two examples he gave, making money and winning an Oscar in whatever your field may be. And it's true, the Nobel Prize is really the highest accolade that there is, I claim, in all of humanity, not just in science, not just in the arts, and not just in peace, but really there's no close second in that it confers, the ultimate capital, the intellectual, FU capital that really sets people apart. And I've known dozens. I had lunch last week with a Nobel laureate who's a good friend of mine. And the thing that's so interesting to me is when people either ask, and he asked me, Adam Rees, who won the 2011 Nobel Prize for discovering dark energy, he asked me, well, what if you did win the Nobel Prize? What would you have done with your life? And I said, exactly what I'm doing now. And so to take back to the beginning of your question, what really prompted this book was I created an experiment, in part, as I admit very candidly in the book, to win a Nobel Prize. I mean, part of it was to understand, most of it was to understand, how did the Big Bang evolve? And I want to talk to you about that. How does the early universe's constituents determine what its future evolution might be? And the deep future, how does its past determine, what the features that we see today? But there was an ulterior motive for me personally. My father was a great scientist, mathematician, very famous, and he cast a huge shadow in my life. And I knew that one way to sort of emerge from his lengthening shadow would be to win something that could not be denied as the greatest scientific achievement. That was winning the Nobel Prize. So for me, it became a source, just like it is for many actors and actresses, to win, the accolades in their field. And then later, once I created an experiment which did capture what was claimed to be the most important signal ever measured up until that point, and rumors of Nobel Prizes abounded. By that time, through a series of events, I was no longer in a position to win the Nobel Prize for the experiment that I created, in kind of an ironic twist of fate that actually has a lot in common with a lot of Silicon Valley or business startups, kind of intrigue and interests I described. But ultimately, I came to see the Nobel Prize for me as an idol of sorts, so something to pursue for the sake of pursuing it, not the least of which to have this kind of everlasting immortality, not too dissimilar from Becker's denial of death theory that you so eloquently opine on.
Yeah, it does carry so much cachet. It's hard to describe it, but everybody that wins, just sort of the doors open up for them. They're allowed to write on pretty much anything they want to write on that has nothing to do with their field. Nobel Prize physicist talks about economics, like what, or politics, or war and peace.
I always love hearing. Every 4 years we're told which Democrat to vote for by 70 Nobel Prize winners, or about GMOs and Iran deals, etc., from a condensed matter physicist. So it's but no other prize has that cachet, as you say.
No, it doesn't, and it's no longer the largest cash prize, right? The Templeton Prize, I think, is bigger. Is the Breakthrough Prize bigger?
Yeah, the Templeton Prize was endowed specifically by Sir John Templeton to always be worth more than the Nobel Prize. And I think it's kind of foolish. It's kind of like saying, don't fly over my house and take pictures, Barbra Streisand said, and then everyone just went over and took. So it calls more attention to the Nobel Prize. And the Breakthrough Prize can be worth, millions of dollars, 10 times as much as you might win if you're a winner of, and share it 2 ways or 3 ways.
Yeah. So, but when Nobel originally set that up, you describe it in detail in the book about the year before the greatest contribution to humanity or something like that. Obviously, this is no longer the case. I mean, sometimes these prizes are given 30 years after or 20 years after the work was originally done. So why do they stick to some of these other rules, like the rule of 3? Only 3 people can win, and you have to be alive. No posthumous awards. How do you change that?
Yeah. Well, I think, so the 3 main rules that identify as the 3 broken lenses, I call them, of the prize date back to what Alfred Nobel originally stipulated, which was to award a prize for the discovery or invention that had the greatest benefit to mankind made during the preceding year by a single person. And since then, and actually not too long after, they changed the rules dramatically and opened it up to 3 people, which seems, pretty munificent. But don't forget, Alfred endowed this in 1896 when he died, or the will went into effect in 1896. And the first winner was William Röntgen, who invented the X-ray. So a single guy, working alone in a lab, discovered something, and within 2 weeks, it was worldwide headlines that you could see bones in your hand, and you could see the ring on his wife's finger and the bones in her hand very starkly. And that was used for the benefit of mankind instantaneously. And he was sort of the paradigm, in my opinion, for what Alfred Nobel, who was an inventor after all, famously invented dynamite, was accused of being responsible for the deaths of more people than any other person, the merchant of death, that they used to call him, and he wanted to rehabilitate his image, and part of that was to confer beneficence on mankind. And so I joke in the book about certain things that are of questionable beneficence, like the lobotomy and other things, and especially the Peace Prize given to terrorists or to entire continents of militaries of entire continents. And because of that, the question as to how far it's strayed from his original intent is an important one. I would prefer, and as I argue in the book, that, and I've engaged for the first time to my knowledge, I wrote an article in this online magazine called The Conversation. I'm not sure you're familiar with it or not, but so I wrote an article, and it was a original thing. And for the first time that I'm aware of, the Secretary General, Goran Hansen, actually started responding to it. So the first thing he said to me, he said, because I joked, in the book, there's the Nobel Prize in 1912, which was around the time when Einstein had already become famous for special relativity, not yet for general relativity. But in the book, I describe how this guy Gustav Delin was a Swedish guy, and if you want to increase your chances of winning a Nobel Prize, be born Swedish, be born white and male, and you too will have a 3 times higher likely chance than a black woman in America. But the question of what that was awarded for a gas regulation system for use in lighthouses and buoys. And I always joke, I got to, my house this morning by way of a navigating buoy. And that was very important to me. The lighthouse, if it's not there, so obviously it didn't have this eternal bestowment. So this guy Hansen, the secretary for Nobel Academy, he writes online a responsa to my piece, and he's like, "What do you want us to do? Track down all of his heirs and take back the money and blah blah blah." And then I said, "Well, but no, of course not. And then he said the same thing about Rosalind Franklin, because I put in there she certainly did a tremendous amount of work that resulted in the Nobel Prize for Watson and Crick and Wilkins, and they basically stole some of her data. And in recent years, Watson's gone off the deep end and gotten into eugenics and all these other arguments. And so he said, "Well, what do you want us to do? Take away their money and give it to Rosalind?" I kept saying, "Why are you upset? Usually you accuse us Americans of being materialistic and venal, and you're just saying all the importance of the Nobel Prize derives from the monetary control." And I said, as you just asked, prizes were 10 times as much as the Nobel Prize. So it's not about that at all. No prize with the prestige. And that's the most important thing in the Nobel Academy. And it was clear to me when they asked me the year after I was sort of eligible and potentially a winner of the Nobel Prize, they asked me to nominate winners. And in it, they didn't really mention anything to do with the beneficence or the imputed benefit to mankind. And they just said, you can give it to many people, up to 3. And it could have been done decades earlier. And it's got me on a quest, as I'm sure it would with any scholar undertaking this project, treating it as a scholastic endeavor. What did the dead man want? Because as well as anybody, once you're gone, at least in this mortal coil, right? So and actually in Judaism, there's no greater mitzvot, there's no greater good deed that one can do than to take care of someone who's deceased. Because in doing so, you're doing something purely selflessly. They're never going to repay you. They're never going to, take care of your body after you died. And so conversely, I believe that the worst thing you can do is when someone writes down the most famous will in history, and then it's completely disavowed within minutes, almost minutes after his death, and pursues to this day in ways that he certainly wouldn't approve of. So I felt that my duty as an executor of the will almost to make this clear in those 3 chapters in the book.
It's funny. It reminds me of the Yogi Berra line, "Go to other people's funerals so they'll go to yours." Right. So I remember when your book came out, Losing the Nobel Prize, when I just saw the title, I thought, oh, this must be by that guy that worked on the fMRI and got robbed of the prize, and he took out full-page ads in the New York Times. He was pissed, and I looked into it. I looked into it a little bit, and it seemed like he has a case. And the problem was it only goes to 3. Why not expand it to 4 or 10 or whatever? I mean,
right. And in the case of LIGO, which won it, 2 years ago now in the 2017 prize. This question, there was a third person who created the LIGO system and made it work. And this is the Laser Interferometric Gravitational Wave Observatory that detected the in-spiraling cascade pas de deux of 2 black holes in the death embrace, and detected gravitational waves directly for the first time. Huge discovery. And there was this guy, Ron Drever, and he ended up dying about 11 days too late. In other words, he would have been eligible according to the laws of the Nobel Prize if they had announced their discovery 11 days earlier than they actually did. Now, I point out in the book, these black holes were orbiting around each other probably for 50 million years. The collision took place 1.3 billion light years away from Earth, and the gravitational waves travel at the speed of light. So traveling at the speed of light for 1.3 billion years, they entered the detector. The press conference unfolded. Let's just say the whole history would have carried out as it did. And they just happened to do their data analysis a little bit faster. Cross-checks come to. They announced it on January 31st. They would have been eligible. This guy would have won. And that would have kicked out the third person, Barry Barish, who was universally regarded as sort of the fourth most worthy. But this, and so it's really capricious. And in the Nobel citation, they actually write out this guy, Ron Drever. They say, he left the project. And I'm like, they all left the project. I mean, they're all in their 80s now. And that's a big problem with the Nobel Prize. But the fundamental thing that I keep getting back to, and I must say I find it in your books too, and it's not a criticism, but the Nobel Prize and Dawkins' books, et cetera, when he wants to come down on Islam, and he'll say, you could fit all the Muslim winners of the Nobel Prize in a single room at Cambridge College. And to me, it's offensive, but it also points out the fact that the Nobel Prize is really the closest thing I think that physicists might have to not idol worship.
Yeah.
And I call myself out, and I say I was guilty of it as well. And it's ironic that some of the most secular friends that I've ever known are some of the most devout practitioners of the. I was told to get tenure, I might need to be on the fast track to win a Nobel Prize. I mean, it's outrageous how outsized and important it's become.
Yeah. Do you think they'll ever change that rule to accommodate the way science is done now, as you talk about in the book, of large teams? I was at a talk yesterday at UC Santa Barbara. The guy had a slide with, it was just like a comparative animal behavior study, 56 authors, and it's like, wow, okay. So
that's small nowadays.
Yeah, that's small.
I have 257 co-authors that I'm honored to be able to lead on the Simons Observatory, this high mountain observatory in Chile. I'm sure we'll get to, and but the thing is, for me, I'm sort of beyond the Nobel Prize in the sense that it's revealed have so many flaws in my mind, and then the reason that it's so important really persists. So I know we have a mutual contact, Lawrence Krauss, and he writes these books, and almost every single book, and he's one of the most militant atheists, as you know. I don't know, is he one of the horsemen? Is he one of your horsemen fellow?
Not officially, but unofficially.
Not officially, okay. Unofficially. So he in his most recent book, why is there something other, or the most recent book is called The Greatest Story Ever Told.
Oh, yeah, that's right.
Yeah, why are we here? So all of his books have why in them, but they never answer the why question. But anyway, he uses the phrase Nobel Prize, or quotes Nobel Prize winners more often than in my book, which is about the Nobel Prize. And so it's just quite startling that the Nobel Prize still has this prestige cachet, as you say. And I feel sorry for this guy who took this ad. It's like the Groucho Marx, like who would want to be? I mean, it's really 400 white guys in Sweden that are the dominant people that are allowed to nominate. Then, if you're also permanently endowed with the rights to nominate winners, if you won the Nobel Prize, so what happens there? You get the Matthew effect. You get the rich get richer. If you work for me and I won a Nobel Prize, you're 5 times more likely to win a Nobel Prize. Or if I work for you, et cetera. So you have all these biases built into this prize, and then the ultimate bias that comes out is authority bias. Where people, again, like yourself, but with respect, you'll quote so and so, and then you win a Nobel Prize for this if you can discover this, and it's become just a shorthand for humanity's greatest and best and so forth. But really, if people knew how the sausage is made, I think they'd have a different view.
Yeah, that's unfortunate. Dawkins has recently been making the point that no scientist has ever won a Nobel Prize in literature. And that's another shortcoming of the prize, because they look at poets and novelists and so on. Well, why not nonfiction science books? Which of course, I think that's a great idea.
Actually, Primo Levi, wrote this book called The Periodic Table, and it's been called the greatest science book, or greatest popular science book of all time. I think the Royal Society called it that. Well, it's funny because every once in a while, I'm sure you've heard this, like, oh, I just missed out on winning the Nobel Prize in math, or so and so almost won the Nobel Prize in math, and you always know they're lying, because there is no Nobel Prize in math, and there's all sorts of apocryphal stories why that's the case. But now, if somebody says I won the 2018 Nobel Prize in Literature, in 2018, they're lying, because it was canceled last year because of this egregious sex scandal involving the woman who was president, which basically presiding secretary, and her husband, who was having affairs with women allegedly, et cetera, who were hoping to either win the prize or learn who the prize winners were. And the King of Sweden basically stepped in to intervene and say, we have to do a gut check on this prize. And I make the case that all the prizes need that. Hopefully not for sexual harassment, it's awful things that can happen, but hopefully for revaluation. I mean, it's a 118-year-old thing that has only had, in my mind, some negative modifications over those past, century plus.
Well, the year before that, Bob Dylan won the Nobel Prize in Literature, which is like, what? I mean, I love Bob Dylan, but what?
Me too, yeah. Exactly.
So, yeah, but I've sat on enough committees to know how slow they move, so I doubt that there's going to be major changes like that, but it would be nice if there were, and I do hope
I have heard from...
Yeah, go ahead.
Oh, sorry. I have heard from members that, so I'll get, clandestine emails, from people on the committee. So first of all, you're automatically entitled to nominate if you're a Swedish academician or a Norwegian academician or in Scandinavia. So you get these scientists, like I said, 400 scientists from Sweden, Scandinavia, not the most diverse collection of people you're ever going to meet. And just the same, some of them write to me and say, I agree with everything you say in your book. Just they can't come out publicly and say it because it's the monopoly monopoly, right, Michael? So what do all monopolies care about first and foremost? Preserving their monopoly. It's like, well, what do you think Apple's going to do? Just give away all of its technology? No, they're not going to do that. They're a monopoly. They want to keep their monopoly.
Yeah. Now, one last point on the gender bias, the obvious gender bias. Given how much our moral sphere has expanded and how sensitive we've all become to women's rights and so on, are they still biased that way, or is it that the ship is going to take a long time to turn because the pipeline doesn't have as many women in it still coming up, and it takes decades to win a Nobel Prize, and it may just be another 20, 30 years before we have equity?
Yeah, that's a very good point. So one thing I point out in the book is that there's nothing in Nobel's stipulations that say that the women like Vera Rubin or currently Jocelyn Bell Burnell, who just won the Breakthrough Prize, there's nothing that says they can't give the next year's Nobel Prizes to them. Their advisors won Nobel Prizes. Their other men won Nobel Prizes for doing, equal work. And there's nothing in the prize that goes retroactively to some of the greatest, including one of my colleagues here at UC San Diego, Margaret Burbidge, who's pushing 100 now. So if they want to adhere to their own arbitrary stipulation, only added in 1974, by the way, that they can't give it out posthumously. They've done that 3 times. They've given it away posthumously, and 2 of them were Swedish white guys who won the Nobel Prize posthumously. So it's convenient for them. They can change it. And Rosalind Franklin, same thing. They could go back in history and use the prestige of the Nobel Prize to burnish and reform, just like, the Academy Awards and politics is now doing, and bending that moral arc. As I quote in the book, the same quotes from Martin Luther King and et cetera, that we're going to, it'll take a long time, but they could do it and not even have to monkey around with their own rules as they're already keen to do.
Right. All right, let's talk about your research. Whether or not you ever win the Nobel Prize, sort of irrelevant. It's super important because you're pushing back time to as close to the beginning as you can get through this BICEP and BICEP2 and other experiments. So let's just talk a little bit about the geography of the universe. So the further out you look, the further back in time you go, and we know it's 13.8 billion years as far as we can see or whatever. But so just one of these weird topological type questions. So you have this expanding sphere, the universe. That 13.8 billion is just the radius, right? It's just as far as we can see to the edge, but there is no edge or whatever. It's really like double that or even more because it's expanding and so on. So just walk us through how big is the universe really?
Yeah, that's a point that most people don't appreciate, that the actual distance from which we can observe the so-called horizon, the farthest thing that you can see, is actually not the speed of light times the age of the observable universe. And I hope we'll get into the distinction between the beginning of time, the Big Bang, inflation, because those are 3 different things that sometimes are conflated, ironically. And in this case, what we see with the universe that is expanding, and that's been known since Lemaitre and Hubble's observations back in the 1920s, that the universe was dynamic. So first of all, big picture step back. For millennia, people thought the universe was static, unchanging. And even those that were religiously inclined to believe the biblical description of creation, which I hope we can get into, Sir Isaac Newton, he had to contend with why the universe seemed to be so static. I mean, there's only 5 naked eye things that you can see, that appear to have motion. Those are the planets, which in Greek the word planet means wanderer. And so those were varying across the night sky. There's the annual modulation, there's the daily modulation, but it wasn't clear that anything else was moving in the universe until the observations of high-velocity stars in the 1800s, and then later high-velocity galaxies by Hubble and others. And the implication, if you ran a movie backwards in time, was that there was a point in time when all the galaxies that were currently rushing away from each other would have been back closer and closer, and therefore the universe would have been denser and denser, and therefore hotter and hotter. And that point could eventually, if left unchecked, reach a singularity, a point of infinite density, temperature, and infinitesimal size. And this is still 100 years later an incredibly hotly debated phenomenon. But just taking the dynamics of what we know since the evolution of the universe, the point in the evolution of the universe that we have the first moment of confidence in, which Sir Martin Rees talked about. a couple of months ago now in your show, is really about a nanosecond after the Big Bang. That's when we start to, or after what we call the hot Big Bang, which we'll get into these distinctions later. But a nanosecond, if you like, after the beginning of time. And that nanosecond is most mysterious, and it's important. It's not just, well, what's the difference between a nanosecond after the Big Bang and zero? Well, to a physicist, it's an infinite amount. It's the logarithm of that ratio. A logarithm of zero is a pretty small number, negative infinity, right? So in the case of what we're trying to discover is that the universe has been expanding and cooling off since that nanosecond after the Big Bang, making elements, eventually making galaxies, eventually making planets, people, etc. And that movie, if run backwards, suggests the universe began 13.8 billion years ago. But because the universe is also expanding, the distance traversed from us to the horizon is greater by a factor of 3 times the speed of light times the age of the universe. So actually the diameter of the universe, which is roughly what you're asking, is about 100 billion light years. So from one edge of the universe to the other edge, currently, the current proper distance between those 2 points, which could never have been in communication with each other, which never will be in communication with each other, they're expanding with respect to each other faster than the speed of light. That distance is just this incomprehensible size, and yet it's not clear if there's something 100 billion and 1 light years away from those 2 points, right? So it could be expanding into something. It could be another universe just adjacent to ours, and we won't find out for another year or hour or a billion years. And because of that, I think it's very important, to make these distinctions between these different epochs in the history of the universe. And what my research does is tries to push that nanosecond back to a trillionth of a second, to a trillionth of a trillionth of a second, and eventually to a trillionth of a trillionth of a trillionth of a second after the Big Bang. So 10 to the minus 36 seconds. And that's when this period of what's called inflation would have began. And we'll get into the reasons why, but short one-sentence summary, we know that the Big Bang occurred, that a Big Bang occurred, and that the universe is expanding. But to a physicist, there's 2 different properties that are necessary to solve the equations that describe any physical system. It's called the boundary conditions. What is, this system adjacent to? What is imposing different forces, fields, energies from the outside? And then the initial condition. What started the system in motion? A pendulum held out like this in the beginning will have a very different dynamical future than one held, very close to its minimum. And so I'm trying to recover physical evidence for that first initial condition.
Yeah. A mistaken question people often ask, so I'm going to ask you, why is this a mistaken question? What's the universe expanding into?
So I always like to describe that question. If you go out into interstellar space, between the stars, all the galaxies, etc., and you're in intergalactic space, there are on average inside of any cubic centimeter, there are about 420 photons. This makes my friends in Colorado really excited. There's 420 photons from the Big Bang in every cubic centimeter. Now, cubic centimeter is pretty big compared to the size of a photon of this particular wavelength. And so if you ask, well, what's in between those photons? That's what the universe is expanding into. It's really nothing in the sense that there's no boundary, there's no sign, there's no place, through which you can throw a spear, because what's happening is the universe creating time at the speed of light, if you will. So there's no availability. There's no sense to answer the question of what is it expanding into. We think of a meta space sort of what's being expanded into, and the difficulty comes when you start thinking using your our brains are really 3-dimensional equipped objects, but really our retinas are 2-dimensional, as you know, and we synthesize a 3D image, a stereograph, from 2-dimensional images. Well, it's very hard to visualize a 4-dimensional thing, certainly for 2-dimensional images in our retina. And so, the best thing I can say is what is expanding into the same stuff that's between all the stuff in our local intergalactic medium. Basically, it is empty space.
Yeah. And before we get to the kind of the religious connotations of the beginning, how do you get information from a trillionth of a second after the Big Bang? How do you collect that data?
Yeah. So as you pointed out earlier, because light travels at a finite speed, that you can only access information from points in the past. And those points in the past can be pushed back to the point that light began to be present in the universe, which is roughly 380,000 years after the Big Bang. And that the most ancient light that there is called the cosmic microwave background radiation, or CMB, the famous 3 Kelvin or radiation signal discovered by Penzias and Wilson serendipitously in 1965, and I'm sure we'll get into that. And because of the limitation that this light source is a plasma. The CMB was formed when the plasma, the primordial soup, cooled off over 380,000 years, eventually allowing an electron and a proton to condense in a process just like condensation of vapor into liquid water. And that condensation allowed microwaves, or eventual microwaves at that time, light rays or ultraviolet light, to then propagate throughout the universe. And then that freedom of the microwaves to propagate became the CMB, the cosmic background that I study. So in order to go earlier in time, you have to find a way to see through that surface, that plasma, and that plasma is really completely opaque to light and radio waves and gamma rays and any other form of wavelength. So I always make the analogy: if a plane is flying, today as it is, I'm sure in Santa Barbara, we have May gray, so it's a layer of overcast that pervades and gives some hope for people that live outside of California that we don't always have perfect weather.
Right.
But you've heard many times there's a plane flying overhead into Santa Barbara or wherever, and you can hear the plane, but you can't see it. So that's a different form of radiation, and it's not light. You can't see it, but you can hear it, and so it's sound radiation. In our case, we're using a different kind of sound, not really sound, but it's the vibrations of space-time itself. These are waves of gravity, not dissimilar to the waves of gravity that LIGO discovered and eventually robbed Ron Drever of his Nobel Prize. And so these waves of gravity also travel at the speed of light. They have no mass, and they don't interact with anything very strongly. Gravity is the weakest of all the forces. So they can go right through the entire, the primordial soup that is the plasma that's opaque to photons. So we're using to get farther away, we have to use a different source of radiation. In our case, we're using the radiation called the gravitational wave radiation or gravitational radiation. And by doing that, the actual plasma will retain a fingerprint, an imprimatur of the presence of these gravitational waves. And so the kind of logic that you have to keep in mind here is if we detect these waves of gravity via their imprint on these waves of light, so it's kind of like the old-fashioned dark room, right? So you had a piece of film, and then what we're using as the film, we're trying to expose not waves of light, but waves of gravity. But what makes the analogy so complex is that the film is actually made of light. It's actually waves of light, which will get kind of permuted and twisted and curled and modified and modulated by waves of gravity. And if we see that, there is extremely strong belief that the process called inflation will have taken place in order to produce this cosmic gravitational wave background. It's not enough to see it from a pair of black holes over there or a neutron star explosion over here. We have to see it over the entire sky, just like we see these microwaves over the whole sky. And if we did, then it would be very strong evidence, not quite direct, proof of inflation, direct evidence, but evidence that inflation took place. And if inflation took place, we're going to get into presumably a discussion of the multiverse, which is concomitant with the inflationary theory.
Why do you have to be in the South Pole? Why can't you go to Hawaii or someplace nice?
Yeah, my wife asked me that question, when I lived in San Diego for months at a time. Yeah, so the BICEP instrument. So BICEP was an acronym, a tortured one that I created, standing for Cosmic Background Imager of Cosmic Extragalactic Polarization. And it was meant to be a play on words for the muscle that does curls, because the signal that we're looking for is a curling, twisting pattern of light waves. And light waves in the microwave regime are absorbed by water vapor, are absorbed by water vapor, and that's exactly how we make coffee here. You heat up the coffee. I shouldn't use this because actually the glass gets a little hotter than that. But here's a ceramic mug. So this ceramic mug filled with coffee. If I were to take this, put it in the microwave, you maybe have done this, forgot about it, put it in there for 5 minutes or something like that. The water will actually be superheated. It'll be above the boiling 100 Celsius, and then the mug is cool to the touch because the mug is bone dry.
Right. So
microwaves of this wavelength cause water molecules to rotate, agitate, and vibrate, and cause basically frictional heating that boils water or superheats water. But something that's bone dry, like china or porcelain, won't have any moisture and won't absorb it at all. So the lesson from this brief diversion is that water absorbs microwaves. Now, The signal from the Big Bang is in the microwave region of the electromagnetic spectrum. So these microwaves have been traveling for 13.8 billion years across intergalactic space. We don't want them to be absorbed in a water molecule in the Earth's atmosphere. So Hawaii would be one of the worst places, from a microwave perspective. Of course, one of the best places from even not just a vacationing perspective, but from an optical astronomy. Optical photons are find the atmosphere fairly transparent, although it does produce the scintillation, the twinkle twinkle little star that you see. But for microwaves, you want to go somewhere really dry. Well, what's the driest place on Earth that you can go? Well, not on Earth. You want to go to space, but a spacecraft costs about 100 to maybe 1,000 times more expensive than an equivalent ground-based mission. So we decided to put it on a poor scientist satellite, and that was the South Pole, which is about 10,000 feet above sea level. It's funny, you go there and they have a sign, it's like, welcome to the South Pole. We've got 10,000 foot base of snow. No doubt, everything's green circles or whatever. Ski runs. Right. The easiest ski run possible because it's completely flat, high, dry, and oftentimes you're basically a California boy, but I grew up on the East Coast, and sometimes it'd be too cold to snow, and that would always piss me off as a kid, waiting to hear the cancellation for school that morning. But it's too cold to snow, and that's when water gets super cooled, it basically precipitates out, and you get this darkest possible azure skies, just a few degrees above the horizon, and then certainly it's also dark more than 6 months of the year. It's extremely dark. The sun is down below what we would consider evening for 3 straight months at the South Pole. So it's an incredible place to be. It's a very difficult place to get to. It can take weeks to get there, but it's one of the most stable, dry, high sites that there is on Earth.
Interesting. And what's the longest stretch you had there, and how miserable was it to be there?
So they don't, fortunately, professors, have more control over our schedule. We do have scientists there that we hire. These are members of the general public. You can apply for it if you're interested. And I always joke, you get about $80,000. You're outside the long arm of not the IRS. You actually get taxed on it. It's one of the only out-of-country locations where your salary will be taxed. But you can get away from the credit card companies and the mafia. And I don't know which one's worse, but you can get away from both of those. And you only have to work for one night. And so that's pretty good. I always joke about that. It's a long night, but it's only one night's worth of work for $80,000.
Well, yeah, much of your book is a memoir about what that was like, including that phone call you got about your father dying and all that. That was pretty dramatic. Yeah. That's a long ways to be away from bad news.
Yeah.
But now your new telescope, you're working on the Atacama Desert. No, I'm not saying that right. The one in Chile.
Atacama.
Atacama.
Yes.
Yeah, I've been there. I went to those telescopes. There's I forget which array it is. The guy
ALMA.
The ALMA telescope.
Yeah.
The guy who designed them took me up there when I was there for 2009 for the Darwin bicentennial or centennial.
Wow.
Yeah, no, it was great. It's just such an incredible environment. In fact, that structure is featured in the James Bond movie Quantum of Solace, that the structure where the astronomers sleep, that's in the movie. So that's where we were. Yeah, really dramatic. So you're up in that area because that's also dry and high above water molecules.
Yeah, so that's above half the atmospheric. So that's at 17,500 feet. Where you were where the astronomer stay is only 9,000 feet, and atmospheric attenuation of air pressure and water vapor in some extent increases exponentially. So I always joke, if you've ever been to Hawaii, I'll get out of breath, walking up a flight of stairs in Hawaii. It's about 14,000 feet at the summit of Mauna Kea, where some of our projects are located. But I'll get out of breath walking down a flight of stairs at 18,000 feet. I mean, It's incredibly draining. I mean, you're much more fit and you do your biking and everything. So I've often thought about, we should do hyperbaric training and kind of pregame and you really feel like an astronaut when you're there. Not to mention, the volcanic extinct or dormant or not dormant volcanoes that surround us that look like the surface of Mars. But also you're wearing an oxygen tank on your back. You're completely covered from head to toe. It's freezing up there. all year round, even in the summer. And the reason we go there is one of the things I pointed out just a couple minutes ago. To get to the South Pole, it's extremely high, dry, and cold, but it's also dark 3 months of the year, completely dark 3 months of the year. And there's no aviation allowed in or out 6 months of the year for the simple fact that aviation fuel and hydraulic fluid freezes and actually will expand and blow up this military cargo plane, $150 million cargo plane. They don't want that to happen. So a couple of times, a female doctor, Jerry Nielsen, she diagnosed herself with breast cancer, and they couldn't evacuate her in the middle of winter.
I remember that story.
So they dropped her biopsy kit and chemotherapy, and she actually went on to live. Unfortunately, she died not too long ago, but she lived another 5 to 7 years after coming home from the South Pole. So it could take a month to get there for some of my students. I only go for a couple of weeks, so if I would missed a month, took a month to go there, it would be completely disruptive for my teaching, et cetera. But my grad students go for a few months. But Chile, you can be there tomorrow. You could literally get there, in 25 hours from San Diego to 18,000 feet, and start acclimating to that most austere place in the universe.
And what will that experiment do compared to BICEP? Is it along the same lines of pushing back further, closer to the Big Bang?
Yeah, so BICEP was able to push back, we thought, to the very beginning of time, to this trillionth of a trillionth of a trillionth of a second. And but in doing, we sort of fell victim to one of the oldest sort of prejudices or biases, if you will, cognitive biases that you're altogether much more familiar with than I am, but confirmation bias, that we really wanted to see the signal. In my case, I say, as I said earlier, I want to win a Nobel Prize at all costs. And it was very important to me that we see this signal. And even when I started to get inklings that we might be misinterpreting our data or overextending the interpretation, it became clear that we were going down a road, at least, I was going down a road that it would be very hard to retract and come back from. And so BICEP ended up basically having to disconfirm what was considered the greatest discovery, in scientific history up until that point, by many people, including Lawrence Krauss, I said. And this was, more than a little bit embarrassing, but it wasn't a blunder. It wasn't that, we kept the lens cap on the telescope, or we forgot to connect this coax cable that imputed faster than light speed travel for neutrinos, as other experiments did. And we made one of the most fantastic, phenomenal discoveries of all time in terms of its technological significance. We did something that Penzias and Wilson back in 1965, if you just took the rate of Moore's law improvement in technology, it would have been orders of magnitude worse than what BICEP achieved, in the same 40, 50-year period post Penzias and Wilson. So we made an exquisite measurement of dust. So spoiler alert, I don't win the Nobel Prize. Right. The book cover kind of shows this beautiful image of BICEP looking up at the words Nobel Prize, and it's looking through this cloudy dust cloud called the Milky Way galaxy. And as I point out, that dust is very essential to our existence. And as you say in one of your books, you talk about stardust and being golden, et cetera. And we are literally made of the guts of an exploded star about 5 billion years ago. But that dust, as mercurial and wonderful as it is, also contaminates astronomical measurements the same way a water molecule absorbs light waves. A dust molecule can not only absorb light waves, microwaves, it can polarize them. And it can actually trick you into thinking you saw something that you didn't see. In our case, the birth pangs of the Big Bang. And so what the BICEP project has now done is, and I'm still very tangentially involved with the BICEP team, although after the book came out, I wasn't really their number one fan. They weren't my number one fans. But in any case, that team has gone on to do upgrades and improvements to the detection system. And I say the only way that we can really improve upon these measurements of BICEP, they're so exquisite, is to build an experiment that really only looks at dust and tries to get rid of dust all by itself. Mm-hmm. Just like going to space would get rid of any concern about water vapor. So I joke, we're building an enormous space vacuum cleaner, Dustbuster. This is the 30th year that the Dustbuster has been out. It was created in 1979. You as a parent know its utility as well as I do, that it sucks up dust. But instead of sucking up dust, we can't actually do that. But we can measure only dust, and then we can measure this cosmic signal plus dust, and then we can subtract the dust signal alone from the CMB dust. And what will be left, we hope, is the pristine signal from the Big Bang's inflationary epoch, if indeed it took place. So BICEP's working on that still at the South Pole. I joke my next book is going to be about me leaving BICEP. I'm going to call it A Farewell to Arms, but that title's been taken apparently by some Nobel Prize winner. But what I'm doing now is a project called the Simons Observatory, which is a very similar in terms of technological approach, but it's 3 copies of the BICEP telescope, all with different frequencies to measure dust, the CMB, the galaxy, water, etc., and then synthesize that with theoretical models, which is what we do. We model build and we test the models, input assumptions, and then deduce what we can from the data that present themselves. And in our case, we're building this observatory up in the Atacama Desert, and we're also building, BICEP was a small telescope about my height, your height. But these telescopes will be joined by an enormous 6-meter, 20-foot diameter pair of mirrors in a dish and a telescope called the Large Aperture Telescope, which will kind of be a sentinel scanning over the same fields as these small telescopes and removing contaminants that get in the way of the signals we're trying to measure, most particularly called gravitational lensing, which we can get into if you're interested.
Yeah. Well, this is a good place to transition to the ultimate creation type question by asking a cosmological retard question like retards like me ask, which is what banged? That if the Big Bang created all space and time and matter and so on, well, what was there that it banged? And so now we're hitting bedrock here of how the whole thing started. So what do cosmologists think about that? How do they think about that more likely?
Well, so the first thing, and you mentioned this, and I was surprised that Lord Martin, my good buddy Martin Rees, who loves my book, but he said, I just wish you didn't mention the Nobel Prize in it, because he actually doesn't like the Nobel Prize very much either. I don't know if you guys got into that.
No,
he doesn't care for it. Now he actually wrote I think he wrote a Scientific American op-ed about it, or a Guardian or something,
really?
2 years ago when the LIGO won the Nobel Prize. But he's very much opposed to some of the way it distorts scientific history. Same things that I do. I mean, none of what I said is original, to me. It's just I synthesized it in a way that most people tend to agree with the whole package and I was a nominator of people and possibly close to being a nominee myself. So a little different than most people have presented. So what bang? Well, first of all, the Big Bang, and Sean Carroll's another friend of ours in common, and he eloquently says, really the Big Bang is the marks, either depending on which way you're looking at it, going backwards in time or forwards in time, it either marks the beginning of our ignorance or the end of our ignorance. In that, as I said, we really understand things very well using the laws of ordinary physics, quantum mechanics, statistical mechanics, all the laws that you teach to your undergraduate physics majors. We understand those properties in the universe in the aggregate. We don't know what every single proton was doing, just like even the most brilliant statistical mechanical physicist doesn't know every air molecule in this room what it's doing, right? It can only predict on aggregate. So we know the laws of physics back to in time from 13.799 billion years ago today, back to about a nanosecond. But theoretically, anything goes at that point because we really have no description of nature that allows us to proceed farther back in time than that nanosecond. If we were to be successful, if BICEP, in a counterfactual universe, BICEP was correct, confirmed, verified, dust was not a problem, as we originally thought, then we would have the first evidence for the physical conditions of the universe immediately after the beginning of the universe. Now, I want to make a clear distinction. The Big Bang is sort of what you can think of the Big Bang is what Hubble discovered. It's not what Stephen Hawking was looking for, where you're really looking at what happened at time equals 0. So, famously, Stephen Hawking was pursuing the singularity, actually what happens at a singularity. But really what Hubble discovered and what was later called in a pejorative sense, you probably know this by Fred Hoyle, who was a first-degree colleague of mine in San Diego. He died before I got here, but his close colleague, Jeff Burbidge, whose office I now have at UCSD, they were proponents of the steady-state model for decades. Now, what is steady-state model? It's basically an extension of what people have believed since Newton and even up until the time Einstein was shown data from Hubble They believed the universe was static and eternal and basically unchanging. When they were showed that the universe is actually evolving and galaxies are being expanding away, they had to tweak their steady state because it wasn't steady anymore. It wasn't so steady. They had to add epicycles to it. They literally added epicycles to it and became called the quasi-steady state cosmology. And that held sway until 1965 or so, when Penzias and Wilson started to come in with physical data about what the conditions of that first nanosecond were like, or after that nanosecond. Going back in time, we don't know if there was anything to bang, and we don't know what the description, the correct laws of nature were. And I just want to point out two things. If indeed, so whenever I say Big Bang in the future, I hope you'll interrupt the speaker, even if it's Lord Rees, and say, do you mean the evolution of the universe, like what's called the hot Big Bang, the production of protons, neutrons, croutons? I always get fixated on the croutons. Production of material. Or do you mean that first instant of the origin of the universe? And that's very critical, because what the inflation subject explains to us is how the hot Big Bang could have been sparked. It doesn't say anything about how the universe itself could have come into existence. So what I like people to contemplate is, if there was a singular beginning of time, as Hawking famously said, asking what happened before the Big Bang is like asking what's north of the North Pole. Although I always say it's Santa Claus, everybody knows that. But what's north of the North Pole? It's a coordinate singularity, so it's the origin of a coordinate system. So in that sense, if he's right, time didn't exist before the Big Bang. Now think about this. How does time pass when there's no time? That's one question to ponder. Right. Does time even flow? And I don't even mean like Zeno's paradox, but then there is something related to Zeno's paradox, which is, if the universe did begin in a singularity, it was infinitely hot, infinitely dense, and it had this infinitesimal size. Now, today, we know the laws of nature are very cool, comfy, and cozy, right? We're existing in a roughly 300 Kelvin room temperature Earth right now most of the time, and it's getting warmer. But anyway, the universe is roughly consistent and compatible with life. But how do you go, and there's never been an example of this, infinite, how does something transition from being truly infinite to finite? There's no example where you can actually demonstrate that takes place. And yet every physicist that I know has faith that that process could actually take place. So the answer is, we don't know. We do not know. And what I love about Sean, I disagree a lot on his theology. I think his cosmology is so much stronger. But I certainly do enjoy that he said his theology.
Well, he's an atheist.
Well, but he grew up. Yeah, something. I'm saying when he speculates on theism and theology, I think he gets a little bit off track, and we can talk about that. But he says when somebody tells you about something before the first nanosecond, basically the most honest thing to say is, we don't know.
Yeah, well, I agree, and I think here we're hitting a a transition from a scientific question to a conceptual question. How do you go from something to nothing? And here, I sent you this, issue we did on why is there something rather than nothing, which I wrote. Yeah. It's just a compilation of what other people have thought about this. I mean, just this whole idea of nothing is inconceivable. Not just emptiness, not just blankness, and not just emptiness and blankness forever, but not even the existence of emptiness, not even the meaning of blankness, and no forever. It's literally inconceivable. At some point, it seems like we just hit an epistemological wall. Our brains are just not wired to even conceive of this, and you're not going to get any information from before the Big Bang from any telescope, no matter where you are, because there's no information.
Well, actually, so that was the one thing I didn't have yet a chance to really get into, and I think it is the most important thing that I study. It influences me philosophically, maybe even theologically, et cetera. And that's the notion, and it's certainly in terms of what it means to be a scientist, and that there is an alternative to the Big Bang. And that's another version of the cyclic universe, and it's been postulated by none other than one of the three founding fathers of the inflationary theory, who I joke, Paul Steinhardt, who's the Einstein Professor of Theoretical Physics at Princeton University, and I joke, he's kind of denying paternity for the child that he sired, and that is that he postulates, as did many people before him, but for the first time with some interesting and theoretically well-motivated concerns about how the singular Big Bang, the inflation multiverse that is concomitant with inflation, how those can be completely superseded and replaced by a very well posed answer to the question of what happened on the Tuesday before the Big Bang. And that's that there was a hellish, fiery deathscape of the collapse of a preceding universe. And there's been tremendous amount of work in the 19 years since he first proposed this model, and then Sir Roger Penrose has a competing model. These are all alternatives to inflation. Now, you might ask, well, why do you need an alternative to inflation? It seems to be accepted by all these cosmologists, and there was a letter written last year to the editors of Scientific American. I'm sure you might remember this. Paul Steinhardt and another colleague from Perimeter Institute, another colleague from Harvard, wrote an article basically claiming that inflation was not only wrong, but it was bad for science, that it actually invalidated the scientific method, and then further and talked about their own model, cyclic cosmology, the bouncing model. And in that, they then got responsa. It's kind of like the Roman Empire, responsa prudentia. You'd write something and then, 7 years later, you get a response. It was signed by 33 cosmologists, including Alan Guth, who's credited with creating inflation theory, and 5 Nobel laureates. There they are again. And they're signing a letter, a petition, mad at Scientific American for publishing this article. And they're basically, appealing to authority. And these are, many of them are my good friends.
What was the
Sean was one.
What was the article Scientific American published?
So the original article is called "Pop Goes the Universe" by these 3 scientists, including Paul Steinhardt, saying that inflation has basically irreconcilable problems that make it fundamentally untestable. And that it violates the mores of the scientific method that have been used for 400 years. And then there was a response to that letter signed by 33 cosmologists, including 4 or 5 Nobel laureates. And a contributing author was Alan Guth at MIT, and David Kaiser, all of whom are friends of mine. I mean, I know every single person on that list. And it was just surprising to me because, if I write an article and let's say it's wrong, okay, so then I have to retract it. But if you just disagree with it, and the kind of controversy over this was so hot. I mean, it was thousands of shares and hits, and people are so interested in this. And it made me feel like this is not at heart a scientific argument. There's something else at work here. And these people, I doubted and was quite skeptical, actually, as to the motivations. Why are these people writing a letter? Instead of an article, write a response, write your own model up and submit that to Scientific American. And that didn't happen. But anyway, to get back, there is a very well posed, and better yet, it's actually testable using the laws of the scientific method that postulates the universe didn't begin with inflation, and that there was an answer, as I said, to what happened that Tuesday before the Big Bang. And that's this collapse in a previous cycle. And it has a lot of other virtues that we can get into as well. But
what would be the information that would come through into our universe from one of these previous universes? Is it gravitational waves or something?
Yeah, so it's actually the absence of gravitational waves, which is so interesting. So it predicts the same formation of structure, the formation of the elements, the formation of vast clusters of galaxies on tremendous cosmic scales. It predicts all those features. But what it doesn't predict is the one kind of unique sine qua non of inflation, which are waves of gravity. So that is exciting because that means if you measure waves of gravity, you not only prove inflation, or that inflation itself is very well motivated for in some sense beyond a reasonable doubt, but you falsify an entire class of models have been around for 3,000 years, perhaps, which suggests that the universe is cyclic, or it's kind of infinite cosmological karma coming back into and out of existence. So from that perspective, it has to match all the observations that the inflationary model matches, and it does. But what's interesting to me is that it does not have nearly the attention, the cachet. It doesn't tell the story, and I think that that's almost a religious statement. That the reason in Big Bang is so popular. It as Hoyle said, it really taps into people's creation myths.
Yeah, that's right.
The greatest story ever told.
So the answer to the question, what was there before the Big Bang, or what banged? So we have we don't know. We have the cyclical universe and a creator, right?
Yeah.
Now, and so how do we determine which of these is the correct one? And how would a creator who created the Big Bang or whatever, how is that a scientific answer, or is that just a faith-based answer, that a gap filler, as it were? Why not just stick with I don't know?
Yeah, it's interesting because a couple weeks ago on Twitter, I think you described me as a theist, and that's I'm sorry, I'm probably more theologically inclined than you are, but actually I consider myself a devout practicing agnostic,
Oh,
and I think you
really?
used to call
Oh,
yourself
okay.
you used
Yeah,
to. Yeah, so but it's very important because I think you used to call yourself a militant agnostic,
that's
which I
right.
thought was cute,
I don't know,
uh,
and you don't
but you no longer
either.
do that.
Well,
Exactly.
it varies depending on what everybody calls me. I mean, the word atheist used to be pretty negative, so I avoided it. Now it's
Yeah.
become a little more acceptable. So here's the distinction I make between ontological and epistemological. Ontologically, I think agnostic is the right word in terms of how Thomas Huxley meant it when he coined the word in 1869. Not knowable. There's no
Mhm.
experiment we're going to run that's going to ultimately determine whether there's a God or not. Now, when you're walking around in life, you're not a perfect agnostic in that sense. You act as if there is or isn't a God. So I'm an atheist in that sense.
Correct.
Um,
Hmm.
but you made that video, that Prager U video, in which you said that believing in the multiverse takes just as much faith as believing in God. So
Yeah.
how do you square that circle with what you just said about we don't know really, and the cyclical universe might be a testable hypothesis?
Yeah, so for me, my predisposition is towards something like the psychic universe for a variety of reasons that are some scientific and some kind of hunch, based on, it's interesting. You've had on these wonderful, eminent colleagues and friends of mine, and they're all theoretical physicists. They're all cosmologists. I don't think you've ever had on an experimental cosmologist, someone who's building telescopes, and maybe you have, but I haven't been able to
I
find
don't
that.
think so.
And they write great books. They write, Brief History of Time. They write, Sean's Big Picture. And I always joke, it's pretty hard. Or wormhole books, and the Kip Thorne you've had on. He's another theorist. He wrote a book about wormholes and black holes and time. It's pretty hard to put a wormhole on the cover of your book. It's gonna it's gonna
Right.
eat up your audience. But for me as an empiricist, I think it's a different perspective in terms of how we actually use data that we collect, and we know the warts of the data much better. I love my friends that have won Nobel Prize winners, the theorists. It's very hard to communicate to them the limitations of data. I'll give you one example. This is a counterexample to my, he's actually believes in a cyclic universe, Sir Roger Penrose. So Sir Roger Penrose and I are friendly. He endorsed my book, and I've spent time with him, done podcasts with him. And he has this almost religious conviction in the cyclic model of cosmology, so much that he was willing to take as evidence for the veracity of his model, which he calls like Hawking points and black holes permeating through. He was willing to take an image that our team had made basically purely for publicity reasons. And that publicity image, it had no scientific content. And it's like the black hole image you probably saw a couple of weeks ago. That has no scientific content in it. It's very interesting. It's beautiful. And that's why it was shared by a billion people. But it has no science. So if somebody's using that to prove the existence of black holes, that's a misuse of scientific data that any experimentalist would know. But the theoretician or someone who wants to confirm his or her model might not be either aware of or maybe intellectually honest enough to display. So when I say I'm an agnostic, first of all, I want to get to what my definition of what I am is. The way that I differ maybe from the agnostic aspects of you, or just somebody who says, like Martin Rees says, or I'll say Freeman Dyson. Freeman Dyson's an agnostic, and he's another friend. And what he says is, the origin of the universe is a great mystery, and the laws of physics are a great mystery. And it doesn't mean by any chance that, two mysteries equal each other, right? That's not what he's, but he's saying, what could be more fun than solving these puzzles as to the existence or lack of existence, or the existence or lack of existence of God? And for me, I talk about in the book, somewhat tongue in cheek, I set off as an experimentalist to disprove the Bible. Because actually, it's kind of a pain to observe the Torah, as in my case, as a practicing Jew. It's a real pain. I can't work 25 hours a week. I have all these holidays. I have to, spend special food and do all this
So
other
you're
stuff.
a practicing Jew who's an agnostic, so you don't actually believe that there is a Yahweh God, or do you?
So I actually don't know. Right. So my feeling is I act in the way that a theist does. In other words, I go to temple every week. I educate my children. I speak Hebrew. I understand the classical arguments in the Talmud. I've read most of the Talmud. I don't understand it, but I understand it better, than Lawrence Krauss does, and I understand it much better than Richard Dawkins does, and I understand, cosmology much better than my rabbi does. And what I see as my unique role as being able to give self-help advice or give actually a criticism. I like to critique both sides. I critique my Orthodox rabbi. I talk to him about the serious lacunae that he has in his understanding of science. I say, Rabbi, if you care so much about God and you're so fervently in belief of God, I say this to my Muslim friends as well, and my Christian friends certainly. I say you should learn science. If there's any hope of getting to, there's not going to be some message transmitted from, from the beyond, and it's going to be in Hebrew or Aramaic or Latin or whatever. It's going to be in the language of science. And if you want to understand God, if you truly believed in God, I say to people like my rabbi, et cetera, you need to learn more science. And I always get this result. I hate, it's like, oh, I'm not good in science. Well, imagine if I said, I'm not good in English,
Right.
me don't speak good words, me stupid. Like, I mean, you would have no respect for me as an intellectual. And these are intellectual people, and you've interviewed them, and they're not dumb people. Ben Shapiro, I think you can put him up on a list with anybody in terms of his raw intellectual horsepower.
Yeah, he's a smart
He
guy.
believes in the literal 6-day creation story. I don't.
Yeah.
So he believes in certain miracles, etc., that took place, and he admits he has pure faith in it. I am more in the camp of I am fascinated. I love getting experimental data. So one of my friends is Richard Friedman, Dick Friedman. He wrote a book called Who Wrote the Bible?
Right.
He was a professor at UC San
Oh, you
Diego,
know him.
best-selling
Yeah,
book.
yeah. He
He
spoke for me back in the 90s with that book, I think.
Oh, yeah?
But there was a sequel to that one anyway. Well, so why are people like, why is Dennis Prager and Ben Shapiro praising your work? Is it maybe because you're just not a militant atheist? You're more willing to just say, I don't know, but you don't believe that there is a deity reaching into the world, stirring the particles to cure cancers or whatever.
No, I actually don't believe it's an act kind of, I mean, I think the theodicy question, I think the problem, I think that there's no way to falsify the existence of God, as you know. There's no way to directly subject it, and this is where I have problems with Sean Carroll and other examples where he cites sort of like the extravagance of the universe. He says, look at the Hubble Deep Field. Like, what are all these galaxies doing here? And I say, he's like, no creator that I know would create so many galaxies that have no effect on life on Earth. I say, Sean, like 80 years ago, we didn't know about the existence of barium, radioactive barium. And we say, oh, like somebody told it, what's the point of unil quadium, element number 114? No, it would have no point. But wait till it does have a meaning and have it. I think those are kind of simplistic arguments. And my problem with, look, if we could solve this question, the existence of God, then everybody would believe it, and then nobody would believe it, by the way. One of the things I like most about Judaism, and to a lesser extent, you pointed out that I'm practicing Jewish, but I was an altar boy in the Catholic Church for many years. I have a kind of a torturous,
Right.
I'm a member of a very big club, club of Orthodox, boards of directors of synagogues who were once altar boy. Thousands of us all around the world. But in my case, there's just complete, undeniable benefits of practicing religious life. And the community and the culture. And I actually see this in my friends that have started this organization, which I don't know if you've spoken to, called Sunday Assembly.
Oh, yeah.
The Sunday Assembly. And so what do? They get together every Sunday or every month on a Sunday, and they sing songs, and they're not hymns. They read from Woody Allen or Philip Roth. And most of them are Jews, by the way.
A little like the Universalist Unitarians, and So this to me taps into the social nature of our species. We need to get together, social capital. We need community, and so on. Most of my Jewish friends are atheists or agnostics, but many of them practice. So it's the culture, it's the community that has value, and yes, definitely religion does a lot of that kind of thing. Whether there's a God or not is kind of irrelevant. That's just kind of a social and human behavioral aspect of it. But still, let's just think hover over this for a moment of what do you do when we don't know the ultimate answer to this question? Where did we all come from? Where did the universe come from, or so on? And there is no answer at the moment. So why not just say, I don't know, and leave it at that? And I think there's a problem in as much that most of us going through life want to have some kind of an answer. And if you can't decide either way, why not choose the God answer? If that then sort of tags on to all the other things about religion that are useful. And I think this is one reason why people do that. You don't quite do that, though, or do you?
Well, in some sense, I do. I mean, as Jesus said, you judge them by their fruits, and by their deeds you shall know them. In other words, when you see a religion, you can appraise it, based on on its claims, or you can say, well, what are its practitioners? What is its life like? What are the people who practice it like? And is that something you want to emulate? So, for example, in the case of Judaism, where people believe, and I don't, and this is why I brought up Friedman. So what's interesting about Friedman is he is an extremely scholastic scholar. He wanted to be a rabbi, and it's too bad he would have had a good career as a rabbi. No, he has a great career, and a very distinguished professor working on a huge film series for Netflix or something now about his book, Who Wrote the Bible. And in it, in his most recent book called Exodus, he actually makes a scientific and cultural and archaeolinguistic argument that the exodus from Egypt actually happened.
Really?
And it would be fascinating for you to have him back on. It's not at all the way the Torah, the Old Testament, describes it, but he has really almost unimpeachable description of what the evidence is. And yet I asked him, well, so do you believe now? Because he obviously is, he claims he's an atheist. Now he sent his kids to Orthodox day schools, and some of them I think are still very religious and practicing. And so I was like, well, how did you square that circle? How did you reconcile your doubt? And he's not a scientist, but he has, archaeological and otherwise evidence for it. And it comes down to, the fruit. What is religion producing of value? And you can ask, if there's no value and if it does harm, obviously I think that's a negative, that has negative consequences. For me, in a practical standpoint, I find the fruits that I've benefited from practicing as an agnostic. That means I'm looking for errors. I'm looking for flaws. I take issue. There are all these biblical apologists that are Jewish scientists. I won't name them because I don't want to embarrass them. But they put, and this is stuff Ben eats up. Ben Shapiro eats it up. He loves to hear it. And I find he's just subject to confirmation bias. And I talk to him about that because when you hear this, but people make their living off this, Michael. And it's an industry to Christian apologists, Jewish apologists, etc. And I find that intellectually dishonest, and that you should be, but you should also be on the other side. You should be intellectually honest on the other side. So when Richard Dawkins talks about the Old Testament, and he literally distorts in language, I mean, he changes it, and then this Dick Friedman brings this up. He'll go out of his way to distort the language to make it seem like Jews are currently and used to be very chauvinistic, elitist, and using language and archaeolinguistics in a way it's not meant to be. So I do view myself as sort of a rare person in that. And Dennis Prager is relatively similar to me. I mean, you asked about the video. I do think that there is a certain amount of religious faith that it takes to be an atheist and to be a scientist as well. And I think it's almost laughable. And you outline this beautifully in Believing Brain. You take the greatest scientist in history, Galileo, and you really dissect, what he did wrong and why he did these things wrong. And I talk about it in my book too. I mean, he had this theory of the tides on Earth because the Earth is rotating and sloshing ocean water around on its surface. But what was it rotating around? The sun. And that was to bolster the Copernican theory. Completely wrong. We don't have tides because the Earth is in motion around the sun. So nowadays, what's the modern equivalent of that? It's inflation. It's the multiverse. It's the explanation of fine-tuning because we have to somehow, as a physicist, explain the fine-tuning, the difference between the amount of inflationary energy density that we would measure, in the early universe versus the late universe. We have to understand that. We have to understand this pre-cosmos existence, and we have to understand if indeed the universe is accelerating the way we see it, why is it so exquisitely fine-tuned? And there are all sorts of anthropic arguments. And the very term yeah, go ahead.
So the multiverse is different than the cyclical universe you're talking about.
They're diametrically opposed.
They're diametrically opposed. And would you say the same thing? We don't know because we have no evidence for it, but it's not a crazy idea or something along those lines. How would you characterize it?
Right. And in fact, I say, in my next, kind of works that I'm going into in the future, I don't know if I have energy to write another book. But
you do. You got to do it. You have to do a follow-up on this.
But what's so exciting? If you prove the cyclic model was correct, you'd basically be falsifying the Torah. I mean, it's the only way I know that you could say that there's multiple universes in time. You can't show that there's multiple universes in space unless we're lucky enough to collide with another universe.
Well, why couldn't the Torah just be describing this particular cyclical bounce, and it just doesn't go back any further, and God could be 8 cycles back or whatever?
Well, I guess it would depend on what the meaning of beginning is, right? So
Yeah,
Bereshit bara
right,
Elohim, Bereshit in the beginning. So it's
right.
the beginning. It's the same problem I have with Alfred Nobel. The person who did the work. Did he
Right.
mean one person? Did he mean multiple people? And did
A
it mean
beginning.
the beginning? Now, the Torah, by the way, and then I'll have my rabbi, I love, and he'll start saying, well, the Torah, the Talmud, now they'll go to the Talmud. And that's always, kind of like the footnotes, and you got to be careful. It's the second most holy book, but in some sense, it contains a lot of, kind of apocryphal stories and so forth. But anyway, in the Talmud, it says apparently somewhere that God created the universe 80 times before this universe started, and all sorts of other things. But, I think the big picture things that no one ever talks about in the atheist community, who seem to have rebranded themselves as humanists. Now Sean calls himself a humanist,
The reason,
which is not.
I do that too, to a certain extent. The reason for that is because we don't want to define ourselves by what we don't believe, because that doesn't go anywhere, right? So humanism, we believe in positive science and reason and logic and empiricism and rights and civil liberties and justice and fairness, and there's positive attributes. But let me go back 1 second here, and I have a hard out, unfortunately, in a few minutes. So let's kind of try to drill down and get to the bottom of this. My friend Martin Gardner, the late Martin Gardner, one of the founding members of the modern skeptical movement, Scientific American, and so on. He called himself a fideist. Now, this used to drive atheists crazy. He said, when it comes down to certain big questions, God and free will being the two big ones, where we can't decide one way or the other, if it makes a big difference on how you lead your life, and that has positive implications for you and society and so on, it's okay to just make the leap one way or the other, whatever works for you. So this is William James pragmatism. Fideism is a branch of pragmatism. So Martin believed in that there's a God. And he said, now look, I can't prove it. I think the atheists have slightly better arguments than the theists, only slightly better. It could go either way. I just assume that there is a God, there is an afterlife, prayer works, and so on. And, people like Dawkins are like, oh, my God, Martin, how can you do this? It's like, well, you can't prove it the other way. Yeah. So, I always respected him a lot. So it's like, okay, I get this. And so I could kind of see how someone like Jordan Peterson, who everyone's trying to pin down, well, what is it exactly you believe about God and religion? And, I think he recently said, I act as if the Christian God is real and Jesus was crucified. Now, when you ask him about the crucifixion, he'll go off on the metaphor of we all have to bear our own cross and that sort of thing, which, okay, fine, I get that as a metaphor. But was there really a guy named Jesus who was crucified and then resurrected and so on? There he's harder to pin down. But if you take it back to Martin Gardner's idea, acting as if, there is a cross to bear, there is a God, there is purpose to life, does change your life. Therefore, it's a pragmatic way to lead your life, whether there is really, ontologically speaking, a God or not.
Yeah, I mean, it sounds to me, and I thank you for referring that to me, but it sounds to me like a kind of modern version of Pascal's wager, in the sense that, if you do act in a way that comports with any of the great Abrahamic traditions, the only ones I'm familiar with, I'm sure in other faiths it's similar. Yeah, I mean, what is there going to be? If there is a God, then is he going to punish you for, oh, no, you were really supposed to eat chicken with milk, but you didn't because you, no, of course not. They're not going to, God would not, if this being has any of the attributes attributed to him. Now, in the case of, acting in a certain way, I like to bring up the 10 Commandments, and the fifth commandment says you shall honor your father and your mother. And I use this in the book as my father's dying, and I had a very difficult relationship with my father, and it wasn't easy at all to honor him, to be honest with you, towards the end of his life, because he had essentially abandoned me as a child, and my brother as well, and that caused a tremendous amount of pain in my life. And he gave me a lot of great gifts and wonderful things too, but it wasn't easy for me, especially at that time when I was launching this experiment that could win me the Nobel Prize and take me back. I felt like, he's sabotaging me again, and he had very difficult kind of relationship growing up. But because I felt this was a commandment, and because there was a reward in the commandment, it's the only commandment that has a reward. Actually, there's two. I don't know if you know this. There's two commandments that have rewards. I only talk about the one in the actual 10 commandments, but there's 613 Jewish commandments, and 10 of them are in the Decalogue, the 10 commandments. And the fifth one says, honor your father and your mother, so that your days on earth will be long. And the other one in the Torah that promises long life is, if you see a mother bird in a nest, and she has her eggs there, you shall shoo her away from her nest before you take the eggs. And I'm like, what the heck? Like honoring your parent, okay,
Yeah.
that makes sense. But like honoring a parent of a
Right.
bird egg, who cares? But the Torah is saying something, that you can't really divine the reason, if you will, for why these things have rewards. And it's the metaphor that you shouldn't try to see if a given, mitzvah or commandment has a reward. You should not necessarily think that you can necessarily understand it, but you should practice it. And in this case, it's easy to practice shooing away the mother bird. It's very hard. I mean, you're not commanded to love your parents. And I think that's very wise. You're commanded to honor them. And why? Because they kind of acted like a god to you. They actually brought you in, assuming they didn't abuse you. And thankfully, that's pretty rare. And my father didn't like physically, sexually, anything like that, God forbid. But in the case of, it's a very difficult thing to do. And I would not have done it if I didn't feel like there was some source of wisdom, divine or not, that was compelling me to do so. And in the end, I do feel like it did add days to my life, or maybe just life to my days. And I think that that's something beautiful about that. So I'm a pragmatist in that same sense that it sounds like Martin was. And I don't, what I say and I try to give permission to people in the, and it disturbs me sometimes when people will take that and say, oh, see, this astrophysicist proves that God. I don't say anything of the sort. The title of the PragerU video, which Dennis selected, not me, the title is What's a Bigger Leap of Faith, God or the Multiverse? And it's very important. And my original title, it's not like and that was the only thing he changed, by the way. It's not like he's going through and editing the physics.
Right.
And he only changed that. And my original title was When Scientists Worship Idols. But if he didn't like that, and because I want to tie it into.
You know what that should be the title? You know what that should be the title of your next book? I like that.
All right. Well, maybe you'll.
No, really, seriously,
help.
I think you should write a book about all this, Brian. This is really important stuff. I think this is a space that has not been carved out very deeply by scientists. I mean, you have the scientists that are blatant theists, and their arguments are pretty weak, and people like Dawkins take them apart. Someone like Francis Collins, for example, who I know and like very much, but he seems to have sort of this logic-type compartments. Jesus is over here, and science is over here. You're doing something different, I think, that would be book-worthy. You're carving out a space where people can exist in a pragmatic way without violating either the traditions of science or religion.
Yeah, and ultimately, kind of stumble upon happiness in their own way. And that means a lot to me, Michael, for you to tell me that. And I always like to think your name, you know what your name means in Hebrew, don't you?
No.
So El is the Hebrew name for God, like Eloheinu, and me means who, and Ki means is like. So your name means who is like God. So your name in Hebrew, it means that you're God. You're like God.
Well, who am I to argue with that? I mean, come on.
That's right. I made you a believer.
Well, Brian, I got a hard out. I got childcare duties here today. So, but we'll pick up the conversation again and continue on with this, because this is one of these long discussions that really never ends. Science and religion.
I'll have
and
to take it up with you.
All right. Thank you. Thank you so much for coming on the show. All right. Bye-bye.
My pleasure.
Bye-bye.
Bye, Michael.
Bye-bye.